Hey geometry people. Today we're going to talk about similarity. So we already went over similarity just a little bit when we talked about dilations back in chapter 4, when we were making things bigger and smaller, right? But retaining the same characteristics. It was the same looking shape. It was just bigger or smaller than the original. So those two shapes would be considered similar to one another. And so we're going to talk about specifically what it means to be similar without a graph. And then also, um, we'll talk about how we can use similarity to find different measures and things like that on shapes. So here we go. First of all, if two things are similar, if two shapes are similar, that tells us that the corresponding angles are congruent to one another, just like it does when we talk about congruent shapes. So that would tell us the corresponding angles are congruent. And then the second thing it tells us, which is where it's different than shapes being congruent, is that corresponding sides have the same ratio. Okay, so we have corresponding angles congruent, corresponding sides have the same ratio. So this picture that it gives us is, let's say we were going to use a couple of triangles here for it. So let's say I've got triangle A, B, C, and the smaller triangle D, E, F. Okay, so the way that we would write a similarity statement is we might be told that triangle ABC is similar to triangle DEF. And that means similar. So just a little squiggle. It's kind of like a congruent sign, but without the equals underneath it. So that's what similar means. So what that statement would tell us is, first of all, that the corresponding angles are equal, are congruent. So angle A would be congruent to angle D, because just like with congruence, letter order matters here. So the first letter, these two angles go together, they would be the same as each other. So angle A and angle D are the same. Then it also tells us that angle B and angle E are the same, since they're the second letter. And then angle C and angle F would be the same, since they are the third letter. Okay, so that's what it tells us about the angles. And then what it tells us about the sides is that they have the same ratio. So basically, side AB, if I put it in ratio with side DE, since those are each the first two letters, that would be equal to the ratio between BC and EF, which would be equal to the ratio between AC and DF, because that's how the letter order works, right? So instead of AB being congruent to DE and BC being congruent to EF and AC being congruent to DF, like we would if the two triangles were congruent, when they're similar, if I put them in ratio with one another, all of those ratios must be equal in order for them to be similar. Okay, and this ratio of two sides that correspond with each other is considered the similarity ratio. So that's another vocab word here. Similarity ratio. So AB over DE or BC over EF or AC over DF, those are all our similarity ratios. And it would all be the same number. It basically just tells you how much bigger is one thing than the other, or smaller for one thing than the other. It's also considered a scale factor. So if you remember back in dilation, we talked about scale factors. That similarity ratio is also called a scale factor. Okay, and my dog has started barking. That's fun. Okay, so let's actually use this to solve a problem, to do something useful here. I'm going to give some of these sides lengths. So I'm going to say that side BC is 15 units long, that, let's see, let's go with Or actually, just kidding. We're going to say that side AC, no. We'll go with, this is 12. And then we're going to label the ones on the smaller ones. We're going to go 4, 6, 7. Okay. So I know all 3 sides on this one. I only know one side on this one. And I want to use the similarity to find the 2 missing sides. So I'm going to take those 2 missing sides and I'm going to name them X and Y. Okay. And so what we're going to do is we're going to set up some proportions that can help us find our missing side lengths. And there's actually 2 ways that you can find missing side lengths. You can find them using proportions, or you can find them using the similarity ratio. I'll show you both ways. So here we go. Using proportions, what I would do is just take this statement that we have here, AB over DE, BC over EF, and AC over DF. And what I'm going to do is I'm going to take everything in that picture there and I'm going to plug it into my equation. So AB is X. So I'm going to plug that in. DE is 4. BC is Y. EF is 7. And then AC is 12. And DF is 6. Okay. So once I get to that step, now what we're going to do is I'm going to pull this apart a little bit to form 2 proportions. So the first one I'm going to take is X over 4. So you take the one with the variable in it, and you set it equal to the one that does not have a variable in it. So I'm going to set it equal to 12 over 6. Then we can do what we did the other day. We learned about cross multiplying to solve for a missing value. That's how we solve proportions. So I'm going to cross multiply 12 times 4 equals 6x. And then on both sides, I'm going to divide by 6. So we get x equals 8. So that would be the length of side AB. So that's the first thing that we do. So now I've solved for x. The second thing I have to do is solve for y. So I'm going to do the same kind of thing I did here, except I'm going to take the y over 7 this time. And I'm going to set it equal to the one that does not have a variable in it, so 12 over 6. And we're going to do the exact same thing. Okay. So, using our cross-multiplying skills, sorry about that. 6 times y is 6y. 7 times 12, 84. Then on both sides, divide by 6. So we get y, I believe, is 14. Yes. So there we go. Now we have both x and y, and we're all done. So that's one way that you can do any of these. You can set up your similarity statement just like that. You can plug in what you have. You can set the ones with variables equal to the ones that don't have variables, cross multiply, divide, and you're done. A second way that you could do it is using your similarity ratio. So I could take, so the similarity ratio you can find by it's the one that doesn't have any variables in it. So this is my similarity ratio. And I would want to reduce that. That reduces to 2. So I could have also set these equal to 2 if you get a nice similarity ratio like that. And if my similarity ratio is 2, that tells me that this bigger triangle is twice the size of the smaller triangle. So I could also just go, oh, okay, 7 times 2 is 14, so y is 14. 4 times 2 is x. So x is 8. So we could also do it that way. You just want to make sure that you're matching up the correct ones with each other. So it does help to have this set up, because then I know that this one that I'm multiplying by 2 is going to be BC, that this one that I'm multiplying by 2 is going to be AB. Sometimes the shapes are not drawn in the same orientation, so you really do have to pay attention to the letter order in order to make sure that you know which sides are going to go together. Okay, so let's try another one. So we've seen this work with triangles. It also works with other shapes. So this time we're going to go with a rectangle. All right. And it won't always be drawn perfectly to scale either. But here we go. And we're going to have the similarity statement A, B, C, D is similar to E, F, G, H. And again, a lot of times the letters will be in alphabetical order. Sometimes they won't. So you want to pay attention to that. And let's see, we're going to say that this is 12. This is 8. And we'll go 6 and don't know. Okay. And then since this is a rectangle, it's going to have the markings of a rectangle with opposite sides being the same. Okay, so here we go. For this one, sometimes the only question that will be asked, especially in one of these IXL sections that you guys will be doing, is what is the similarity ratio? So in order to find that out, what you want to do is, well, there's a couple ways you can figure it out. You can find it by setting up the fractions or the ratios for all of these and figuring out which one has both numbers. Or with this one, you can kind of eyeball it. You can go, oh, the long side, they both have numbers on them. So 12 and 8 must go together. So 12 over 8 would be the similarity ratio. And then you would reduce the fraction. But the always kind of fail-safe way to do it is to set it up going, okay, AB over EF, because we know those two are the first two letters, so they must go together. BC over FG, CD over GH, and AD over EH. And then you can go through and kind of fill in what you know. So for this particular one, I know AD is 12. I know that AB is 6. And I know that, well, then DC or CD is also 6. I know that BC is also 12, since it's a rectangle. And then for this one, I know that EH is 8. I know that FG is also 8. And I don't know what GH and EF are, so I'm just going to make GH an X, like it says right over there. Okay. So now if I'm just asked for the similarity ratio, all I have to do is go 12 over 8, reduce that fraction. Those are both divisible by 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So my similarity ratio is 3 over 2. But then if I wanted to solve for x and find my missing side, all I would do there is take the one that has a variable in it, 6 over x, and set it equal to the one that does not have a variable in it, or you can set it equal to the similarity ratio. That's the same thing. So I can set it equal to 3/2 if I would like to. That will give me the same answer as if I were to set it equal to 12/8. So then we cross multiply. 3 times x is 3x. I'm going to finish this one up here. 3x. 6 times 2 is 12. Divide by 3 on both sides. We get x equals 4. So my missing side length would be 4. All right, that's everything I got for you guys today on similarity. Make sure you check out those IXL sections so you can get your points for the week. Feel free to email or comment if you have any questions, and have a wonderful day. See you guys later.